SpacetimeDB 2.0 is shipping with all new docs, new features like event tables, a first-party auth solution, and so much more. We even have a collection of new video tutorials to help you get started building your apps in TypeScript. We're so excited to see what you build with SpacetimeDB. There is one more thing though, isn't there? We haven't talked about performance yet. And as game devs, I like to think we know a little something about performance. So how does SpacetimeDB handle a web workload? Well, traditionally your server is separated from your database by the network. In order for your server to access your data, you've got to serialize a query, send it, go all the way through the OS stack, over the network, up the OS stack, receive, parse, plan, and execute, and then go all the way back, all while holding open a transaction and potentially locking up rows. Just pinging the loopback port on my machine without any database work reports an average round-trip time of almost 200 microseconds, with a max of more than 1 millisecond. That's without even touching the network. In SpacetimeDB, your database is your server, so accessing your data takes nanoseconds instead of microseconds, or even milliseconds. That's at least 1,000 times faster. In other words, this is not to scale, this is to scale. So what does that mean for your apps? Well, let's imagine a simplified banking app. We have a set of accounts and we want to process valid transfers between accounts. To simulate a real-world scenario, accounts are chosen at random, but skewed towards popular accounts that have many transfers. Here's the code in SpacetimeDB. Let's run some benchmarks against traditional backends with 50 clients running on separate machines making concurrent requests. Newer hosted solutions and all-in-one platforms struggle. Convex, with its dozens of transactions per second, goes toe-to-toe with pen and paper. Postgres, on planet scale, doesn't offer co-location and pays the price. Supabase only manages to achieve roughly 1,300 transactions per second. But even with multiple servers, the traditional Node.js and Postgres setup tops out at 4,000 transactions per second. Bun does about 20% better. Clearly our problem is that we need something that scales horizontally, right? We need something web scale. Well, CockroachDB on a 5-node cluster only hits roughly 400 transactions per second. Distributed coordination actually slows us down, despite the much higher AWS bill. Only SQLite with its embedded architecture similar to SpacetimeDB beats Postgres. That's fun, but what does real speed look like? How fast is SpacetimeDB? Allow me to answer that question with a question. Do you like my car?